is just not take a formula, but just take a regular equation. How about 3x plus 4 equals 5? All right. And then look at this and say, okay, I'm going to solve this. I subtract 4 from each side. I get 3x equals 1, and then I divide by 3, right? So I get x equals 1/3. Now just suppose for a second that I throw another variable in here, and let's say I say 3x plus 4z equals 5, right? I'm going to follow the same steps. The difference here is I've got unlike terms, 5, I'm not going to be able to subtract and actually combine 5 minus 4z and get something. I'm just going to have the minus 4z as a separate term now. So I get 3x equals 5 minus 4z, right? And then I divide by 3, and I get x equals 5 minus 4z, all divided by 3. Now, this is perfectly fine. This is this is the only way that you're going to get this in terms of x. You're still going to have z over here, right? So in this way, x depends on what you put in for z. All right. So let's just suppose, let's say I have c equals 5/9 f. I think it's minus 32. Pretty sure. Now, in order to get what I want to do here is I want to change this and solve for f instead of solving for z. So I want f to be equal to this all rearranged. So the way to go about doing that is exactly like you would any other multi-step equation. I am first going to multiply. I want the 5/9 to be gone. I'm going to multiply by 9/5 here, right? Times 5/9. Right, so that's going to equal 1, and f minus 32 over there, and this equals 9/5 c. Okay? Hopefully you're all with me here. The 9/5 times 5/9, if you recall the multiplicative identity, that's 1. We don't have to write it. So what do we have? We have 9/5 c equals f minus 32, and then we're just going to add 32 to both sides. And I get 9/5 c plus 32 equals f. There you go. And we could test it. Let's say Celsius was 0. All right. So I put a 0 in there for C, and then I see what I get. I get 32 degrees, which is exactly what it's supposed to be. At 0 is freezing in Celsius, and 32 is freezing in Fahrenheit. That's the freezing temperature of water when it turns into ice, right? So so now let's have a look then at one of the Delta Math items. And I don't think I have Delta Math open, so let me open it up over here. And then we're gonna do one or two of the Delta Math problems. I think that was similar to one of them right there that I just did. So that shouldn't be an issue. And in Delta Math, they call this transforming formulas. Okay, transforming formulas. So So if we take a look at this, and I don't like what I'm seeing, I'm going to take my picture off of there. We take a look at this. It says formula for the volume of a cone is V equals 1/3 pi r squared h, where r is the radius of the cone, h is the height. Rewrite the formula to solve for h in terms of r and v. So what it's saying to me is it wants me to say h is equal to something, right? Now, you might look at this and say, oh, well, we can just divide by h and divide by v, and we're going to have everything. But that's not exactly what we should be doing. What we should do first is you look at the 1/3. We need to get rid of that number, and we're going to do it by multiplying by 3. So we get 3v equals pi r squared h. Now remember, I'm solving for h. I've got I could divide by pi on both sides and divide by r squared on both sides, but I'm going to tell you that you should just take them as a package, right, and divide by pi r squared together. Excuse me. And what do we get? We get h equals 3v over pi r squared. So pretty neat, you know. The thing to remember here is you're still following the same steps as you would if these were numbers with one variable. But, you know, so if there's multiplication going on, you're going to divide. If there's division going on, you're going to multiply. If there's addition, you're going to subtract, and so forth. So, so please keep that in mind as you do some more of these.